All right, which number did you ask me for? Number 6?
Yeah.
Yeah, you probably had a hard time getting number 6 because none of those answers are correct. So I can do it, but I'm sorry, those are all wrong. What did you put in your box?
-4.
Perfect, because that's what makes that, right? Because if I look at this, what makes that right there 0, right, would be -4. And then you should have put a -14. And then what?
A 0.
Perfect. And then what?
And then a 14, and then a -840.
And when you drop this, it should get you a -14. This times this gets you to what, 56?
Yeah.
Then this times this gets you to a -224. A -210, which gets you to a positive 840. Add together is 0. So what this is really saying is, this is saying, don't lose sight of this. This is 14x to the third minus 14x minus 840, and you are dividing it by x plus 4, and the answer to that question is -14x squared plus 56x minus 210.
Okay.
So
I got that. I just was very confused by the fact that there was nothing there.
Yeah, none of those could be right because you can't get an 11.
Yeah, thank you. Oh, could we also do number 1?
Yes, hold on. I want to talk about this one some more because I want to make sure we understand, like, so they could ask me different questions from this. If they ask me to rewrite this as a product of two things, I would write it as this times this, right? Because this is division, right? So this divided by this equals this, then this times this equals that, right? Just like we did when we were in like elementary school. So I could write it as x plus 4 times -14x squared plus 56x minus 210 would get me back to this original thing. So there's different questions they can ask based on that. Number what?
1.
Sure. Can you read it to me?
It says simplify the difference. 5w squared minus 6w minus 6, and then minus 7w squared plus 3w minus 3.
So the way you'd actually want to read this, just so you know, Kelly, and I'm kind of being like a turd, is because I want you to make sure, so like when you read this, you have to read it as minus the quantity, because that's what tells me, and I already knew it, so I put it in there. But just so you know, the quantity means that you put these parentheses, and there is a big reason that those matter. Kelly, why do those parentheses matter with the subtraction sign? Whereas if I just wrote it as minus 7w squared plus 3w minus 3, what's the difference between writing it like this and writing it with those parentheses?
Because you have to distribute the subtraction.
Up here, I have to distribute the subtraction, whereas here, only the 7w gets the negative. These guys would not change their signs. Does that make sense?
Yeah.
So then I get 5w squared minus 6w minus 6 minus 7w squared minus 3w plus 3. Combine like terms, this and this would combine, and that would get me to a -2w squared. Those are used. This and this would combine and get me to a -9w. And this would combine to get me to a -3.
I see what I did wrong. Yeah, that cleared it up. I distributed it at, like, in my head, and then I didn't distribute it as I wrote it down.
Makes sense. That distributing makes a big difference.
Thank you.
Can we go over number 3?
Sure. and this is actually a good one for like the review. This is what my expectation for you to do on the review. It says what, 2x to the 7th minus 4x. So if I was asking you to do this one on the review so you understand what my expectation is for you to get full credit, you would circle this because they're asking about my in behavior. The only thing I care about is that is what? Who asked me for that one?
I did.
So Taylor, what do I care about that? 7, that is what?
It's odd.
Yep. So that's work right there. What else do I care about? That this is what?
Positive.
So I would put this work on here. This would be this is showing my work for, like, let's say the review. So since it's odd and positive, the way I remember this is it always ends the way that this is. So that's going to be the final like end of it. So I know it's going to end up. Since it's odd, I know it starts the different direction than when it ended.
Okay, I was just confused because it said the answer for it was, oh, wait, never mind. Wait, hold on. Did I read it wrong? I might have. Oh, wait, never mind. I read the answer to the review wrong.
That's all right.
But yeah, I got that one, just making sure.
Yep. No worries. Questions?
Can we do number 7?
Sure. So long division, x plus 3 goes into 4x to the 3rd plus 3x squared plus x minus 2. So when we do, who asked me for this one?
I did.
I'm sorry, who was Taylor, is that you again?
Yeah.
Okay, so Tay, what we're gonna do you care if I call you Tay, by the way?
No, I don't. Everyone calls me that.
My cousin's kid is named Taylor, so it's just something that just kind of naturally happens. What we're gonna do is, this is 4x to the 3rd. We are always gonna make this, whatever this is here, I don't care if it's a 2x, I don't care, whatever it is, we're gonna say, how do we make this become this every single time?
Okay.
So x times what would get me to 4x to the 3rd?
Would it be x times 4?
Okay, so what would 4 times x turn into?
4x?
Is that 4x to the 3rd?
No.
Okay, so how do I make x become 4x to the 3rd? I have x. I need to times it by some number and make it become 4x to the 3rd. So I'm asking you for this.
Would it be 4x to the 2nd?
Yes.
Okay.
And notice I'm going to put that above the spot that had the x to the 2nd, kind of like in its place value. That's where I put it in the same place where the x squareds go. Does that make sense?
Yeah.
And then what I do with this is I actually have to multiply this by both of these things. I came up with this number How did I come up with it? Because I said, what times this gets me to this? That's where this number came from, and then I have to distribute to both of them.
Okay.
So when I do that, 4x squared times x is 4x to the third. 4x squared times 3 is a 12x squared. Now, what I taught you guys is instead of subtracting, it's like when Kelly asked me for that first one, instead of subtracting, and then we have a whole bunch of stuff we're subtracting, we distributed the negative sign. That's what I taught you to do here. I taught you to say, hey, instead of subtract this, I want you to distribute the negative to both of these. And so what that's going to do is change this to a negative 4x and change this to a negative 12. And then combine these. Well, a 4x cubed and a negative 4x cubed cancel out. Like that should happen every single time, Taylor.
Okay.
I'm making that front one cancel out. And then a positive 3x squared and a negative 12x makes a negative 9x squared. And then plus x and then minus 2.
Okay.
Now I start the game over again, Taylor. This is my front number. And I want to know how I make x become this now number. And then I just keep repeating.
Okay. So do you want me to find out what the next number is?
Yep.
Okay. It would just be, would it be times 9x?
Close.
Just times 9?
If I said x times 9x, what would that get me to?
Oh, it would be positive 9x squared.
Right, and what do I want?
Negative 9x squared.
So what would I need to multiply the x by?
Negative 9x.
There it is. So you gotta, I know I'm not trying to be, you know, a pain in the butt, but I have to show you that kind of stuff because it matters, right?
Yeah.
So then I take the negative 9x and I have to multiply it just like I did last time by both of those things.
Okay.
And that gets me to a negative 9x squared and a negative 27x. And just like I did before, distribute the negative. When you distribute the negative, it changes both their signs. This still cancels out because one's positive, one's negative. When I put those together, it gets me to 28x minus 2. Now one more time. How do I make x become 28x? 28.
It would just be 28 times x.
Right, and then I distribute it just like we did before. And so this becomes 28x plus, what is that? 28 times 3.
84.
And then change the signs. Negative 86 is my remainder. What do I do with the remainder? I put it in the top, up in the numerator, and I divide it by what I was dividing by. There's my final answer.
Okay, thank you so much. That makes a lot more sense.
Yeah, of course. Sometimes it's just seeing things multiple times, and then all of a sudden it clicks, and you're like, I don't know why I didn't see that the first time. Questions?
Can you do number 15?
Can I do 15? Are you kidding me? Come on. Yeah, I'll do 15.
Okay.
Actually, I can't do 15. 15 is really hard to do. There's no 15.
What?
I thought there was only 14.
Wait, what are you on?
I'm on the 3.4 to 3.5 review, not the exam review.
Oh, I thought you were talking about the exam review this whole time.
Nope, nope, nope. I'm trying to get you guys ready for the test on Friday.
Okay.
Yeah, there's 65 of those. Taylor, what's up?
Can we go over 14? I really didn't get that one.
Sure. What part of it is tripping you up?
The whole thing. Like I just saw it and I was so confused.
Do you understand the Pascal's triangle part?
Yeah, I remember doing that.
Okay. So can you give me Pascal's triangle?
It was like, I don't remember it. What's that thing next to the 2?
A V.
Oh, okay.
Taylor,
Yeah.
did you see Pascal's triangle that I made?
Yeah.
Remember, you only need to memorize this one because then everything else is made by just adding the number. Like you start with a 1, then you add these 2 numbers. That's where the 2 came from, and then get a 1.
Okay.
Then 1, add these 2 together. There's the 3. Add these 2 together. There's the 3, and then 1.
So we would be using the 5th row for it, right?
Well, it's technically really this. If you count, this is 1, 2,
Yeah, the
3,
6th
4,
row.
5. It's really, yeah. So I always say the second number as the 5 is the one you're going to use.
Okay.
Does that make sense?
Mm-hmm.
All right. So now it only asked me for which term though, Taylor. Look at the review. What's it say? It says what is the
3rd term.
So I don't care about these last 3 terms.
Mm-hmm.
I really only care about this one. So I'm going to actually only do the first 3. And the reason I'm going to do the first 3 is because the ones in front of it help me actually figure out what this one is.
Okay.
I don't need to do the rest of them though, for sure. Technically, I don't even need to do the first 2, but I'm going to because they're going to help me to make sure I don't make a silly mistake.
Okay.
Do you get what I mean by that?
Yeah.
All right. So, what did I do next? Do you remember?
No.
Does anyone remember?
You would put the 2v in a parentheses and then the s in a parentheses next to all of them.
Taylor, does that make sense?
Yeah.
Those are that's from right here. And then Taylor,
Mm-hmm.
this starts with the power that this is. So it starts with a 5. This always starts with a 0. And then this one always loses a power, and this one always gains a power as I go to the right. So now the 2v is going to be to what?
4.
And then the s is going to be to the
1st.
and then this 2v is going to be to the
3rd.
and this one is going to be to the
2nd.
But do you see how I really don't care about these 2 anymore? I only use them to help me so that I could figure out what the 3rd term was because that's what they asked me for. So really I don't care about these anymore.
Yeah.
But they helped me get my 3rd term, if that makes
Mhm.
sense. Now I'm
Yeah.
just simplifying this crap. What
Okay.
does it mean to be 2v to the 3rd?
Would it be 6?
Mm-mm. What does it mean to be 2v to the 3rd?
2v 3 times.
So 2v times 2v times 2v. What's 2 times 2?
It'd be 8.
Yes. So it'd be 8. And then what's v times v times v?
V to the 3rd.
And then s squared is just?
S squared.
And I'm timesing it by 10, yes?
Yep. So
You
it'd
see
be
all this is multiplication, so I can actually multiply these two together.
okay. I got it now.
And that's the only one I cared about.
Okay, I got it. Thank you.
Hmm. Questions?
Can you do 4?
Sure. So Kelly, for the remainder theorem, do you remember what I said about it?
I think that was Nina.
Oh, it was Nina?
Yeah,
I'm
that was
sorry.
me.
I saw the little light light up, and she's right on top of you. Sorry. Nina, do you remember what do you remember the remainder theorem, what it states? Because if you don't know that, it's going to be hard to use synthetic.
I do, but I can't remember right now.
Okay, so what happens is with this is telling me what my x is, right? So that means technically I'm supposed to take this 2 and plug it in for all these x's over here. So I should put a 2 in here, a 2 in here, a 2 here, a 2 here, and then I have to do order of operations in the correct way, combine all the numbers together, and I'd get an answer. That's what that asks me to do, right? But what the remainder theorem says is you can actually use 2 as your number in your box for synthetic division, and you can actually do synthetic division, and whatever the remainder is for that will be the same thing as if you'd plugged the 2 in for all the x's. So you would do 2 in your box, and then it would go 1, 1, 3, negative 1, 1, 3, negative 1, 7, negative 5. Do you see where I got all those numbers from?
Yeah.
And then you drop it down 1, 2, 5, 10, 9, 18. 18 times 17 is what, 25? 50. So 45. So that's the answer. P at 2 should equal 45. Did I do the
I
math
see
right?
I see what I did wrong.
Did I do it right? Yep. Okay, you got it?
Yeah, I just totally skipped the 3 and the 2.
Gotcha. Questions? No more questions?